A circle is defined by a set of points that are equidistant from a fixed point. That's this point here, which is called the center. The distance between any point on the circle and the center is called the radius. A circle of radius r and center 0, 0 is shown below. The point xy lies on the circle. If we draw this distance, and that's supposed to be a straight line, which we know is r, we can draw a right-angled triangle, and we know this distance is x, and this distance is y, giving us x squared plus y squared is equal to r squared. And that is actually the equation for a circle centered at the origin with a radius of r. Write the equation. Okay, if the radius is 5, then we could write this, but we don't write this, okay? We write it this way: x squared plus y squared equals 25. If we look at this, if we see this, we know this is 25, which is r squared, so that we know that r is 5. And given circles, the r value is always positive, okay? It's the radius of the circle which is positive. This will be x squared plus y squared equals 1 squared, or just 1, and that's a special circle called the unit circle. So we're now going to use our knowledge of special angles to determine the values of x and y. So we know that for 45 degrees, the sine of 45 degrees is equal to root 2 over 2. But the sine of 45 degrees is equal to opposite over hypotenuse, which is y over r, and in this case, so the sine of 45 is root 2 over 2, our y value is y, our radius is 1, which tells us that y is equal to root 2 over 2. And the exact same reasoning will work for the cos of 45 is also root 2 over 2, and so x is equal to root 2 over 2. X and y are both root 2 over 2. Here, we know the sine of 30 degrees from our special angles is 1/2. Sine theta is y over r, so filling in, we get sine 30 degrees is equal to y over 1. 1/2 is equal to y over 1, so y is 1/2. Right, it's kind of handy when your radius is r, okay? And then by the same reasoning, the cosine of 30 degrees is root 3 over 2, and so the x value, right? Remember, cos theta is x over r, but our r value is 1, so cos theta is just x. Okay, so x is root 3 over 2. And sine of 60 degrees is root 3 over 2, so y is root 3 over 2. And the cos of 60 degrees is 1/2, so x is 1/2 in these particular triangles. A unit circle is shown below with some points on the terminal arms of angles that are multiples of the special angles 30 and 45 degrees. Label the measure of these angles and use your answers from question 4 and symmetry to state the coordinates for each of the indicated points. Okay, so we know that 30 degrees, right, if we think of the 30-degree triangle is, right, we have x here. I'm not going to draw the triangle, but we have an x value here. As a matter of fact, let's do this. 0 degrees. So my x value is 1 and my y value is 0. My x value is the cosine of 30 degrees, which is root 3 over 2, and my y value is the sine of 30 degrees, which is 1/2. For 45 degrees, x and y are both root 2 over 2, and for 60 degrees, the cosine is x, which is 1/2, and the sine is y, which is root 3 over 2. This will be 90 degrees up here, and it has 0 and 1. Now by symmetry, or reflection really, this will be -1, 0, and this is 180 degrees. Okay, this is 30 degrees. It's 30 degrees here, this is 30 degrees in here, so that's 150 degrees, right? It's 30 degrees away from 180. This will be 135 degrees, right? It's 45 degrees. This is 45 degrees from 0. This will be 45 degrees from 180. And then this will be 120 degrees, kind of the same reasoning. These points will transfer over here, only the x values will be negative, but the y values will still be positive. And that's what's going to happen for all of these guys. And -√3/2 and +1/2. The y values are still positive up here. Moving to here, this 30 degrees is down here, but this is 0 degrees or 360 degrees, okay? So this is 30 degrees up from 0. This is 30 degrees down from 360. This is 45 degrees away, and this is 60 degrees away. This is 270 degrees. And again, we can say this point is a reflection down here. It's a reflection in the x-axis. So the x value is still positive, right? And these are in line. They have the same x value, and the y value, instead of being positive, is negative. So this is √3/2 and -1/2. This is √2/2 and -√2/2. And this one is 1/2 and -√3/2. This is 0, -1. This is, again, 30 degrees away, so this is 210 degrees, 45 degrees, 225, and 60 degrees, 240. And we can look either as a reflection of the points above, so they'll maintain the same x values, right? These are in line x, but the y value will be negative. So negative, instead of +1/2 up, we come down 1/2, -1/2. Another way to look at it is this point is reflecting over in the y-axis so that its x value will be negative, right? It's the same distance, but it's on the other side. And then this is -1/2 and -√3/2. And this is the unit circle. Now, the nice thing about this, if you have to learn the unit circle, which you will have to do, is that you really only need to know the first quadrant, this one from 0 to 90, because the rest can be found simply by reflecting, right? We can reflect into the second quadrant, we can reflect this down to the fourth, and reflect the fourth or the second into the third quadrant, right? And every time we move, it's like 30 degrees up from the x-axis, or 30 degrees this way, so 30 and 150, and so on. And the other thing to look at is you need to really know 5 numbers, right? 0 and 1, 1/2 √3/2, and √2/2. And the way that I do this is, if I take my y values, I start at 0 and I just count up. 0, 1/2, √2/2, √3/2, 1. And then I do the same thing going this way from 0 to 1, 0, 1/2, √2/2, √3/2, and 1. Okay, and at this point I don't think we're too worried about learning this, but you will have to learn this in Math 30. You're going to have to know the unit circle. But fairly easy to do. Use the unit circle above to state the exact value of each of the following trig ratios. So we know that the sine is equal to the y value. So the sine of 120 degrees, we just look for the y value here, is √3/2. the sine of 315 degrees. So with a fully labeled unit circle, oops, wrong way. With a fully labeled unit circle and all of the degrees written in, then it's pretty easy. So the sine is negative root 2 over 2. Negative 90 degrees is a negative rotation, so it's a rotation counterclockwise. It's really the same. It's coterminal with 270 degrees, so the sine is negative 1. The sine of 210 degrees, so again back to 210, and the sine value is the y value, which is negative 1/2. Where am I going? Oh, right, this way. So what I'm going to do is just pause this, fill in the rest of these, and then leave it for you to check. Okay, so I'll fill in the numbers and then I'll just leave it and be back with you in a moment. Now we've hit 10. So, here are the other answers, and I'll leave this up for a while. But how do we do the tangent? So if you remember, the tangent is y divided by x. So let's go back, and I'm going to show you a shortcut. So I want the tan of 135 degrees. And I'm not writing for some reason. Okay, there it is, writing. Okay, so the tan. So remember, tan theta is y over x. So for 135 degrees, that's going to be root 2 over 2. Actually, no, I'm going to do the tan of 120 degrees. I want something that's tan of 120 degrees is the y value, root 3 over 2, over the x value, which is negative 1/2, which is root 3 over 2 times, right, kiss and flip, negative 2. Now, what's always going to happen here, right? Since they all have denominators of 2, except for 0 and 1, since they all have denominators of 2, these 2's are going to cancel. And this works out to negative root 3. So the easy way, right, is simply to say it's the numerator of the y value over the numerator of the x value, right? Because these denominators are always going to be the same and they're going to cancel. So this will just be, for 135, it'll be root 2 over negative root 2, which is negative 1. All right, so the tan of 300 degrees is also negative 1. The tan of 90 degrees is the y value, 1 divided by 0, so that's undefined, right? Undefined, it's 1 divided by 0. 120 is negative root 3, okay, over 1, but we're not going to write the over 1. Tan of 360 will be 0 divided by 1, right? 0 over 1, which is 0. The tan of 585, 585, so you know what, I'm going to subtract 360 from that to find the coterminal angle, which is 225, and the tan of 225 is positive 1, okay, it's negative root 2 over negative root 2. The cos of negative 315 is the same as the cosine of 45 degrees, which is root 2 over 2. The sine of negative 510, I'm going to add 720, or actually subtract 510 from 720, so 0, 1, giving me 210 as the coterminal angle. So the, what are we looking for? The sine of 210 is the y value, which is negative 1/2. The tan of negative 150, okay, so add 360 is 210 degrees. And the tan of 210 degrees is negative 1 over, so negative 1 over negative root 3, which is 1 over root 3, right? But we need to rationalize the denominator giving us root 3 over 3. Okay. Now, sometimes you might want 1 over root 3, but in general, we're going to rationalize the denominator. And this is the same as the cos of 90 degrees, right? Adding 360. And the cosine is the x value, which is 0. Solve each equation. So between 0 and 360, cos theta is root 3 over 2. So we're looking for where is the x value? Why is it doing that? And now it's, okay. Where is the x value? Root 3 over 2. And you notice that we're going to have two places, right? X is root 3 over 2 here and here. So there will be two angles, right? So 30 degrees and 330 degrees. Forward one more. Okay, so theta is equal to 30 degrees and 330 degrees. The cosine is negative 1/2 at 120 degrees and 240 degrees. Okay, now cosine is negative 1/2 at 120 and 240. Okay. Boom, boom. And, you know, I'm just going to fill these in and, well, okay, sine. Negative root 3 over 2, and I need 1 over root 2, right, which is also root 2 over 2. So I need negative roots, so I need the y value to be negative root 3 over 2, right? So that's 240 degrees and 300 degrees. So theta is 240 degrees and 300 degrees. And sine is root 2 over 2. Theta is 45 degrees and 135 degrees. And when I want tangent to be negative 1, okay, that means that the x and the y values have to be the same, but one is positive and one is negative. So the x and y values are the same here, so 135 degrees, and the other one where x and y are the same, because they have to divide to give you negative 1. So we need one negative, one positive, so we have 135 and 315. 135 degrees, 315 degrees, and tan theta is root 3. That means I want the y value, I want the numerator of the y value to be root 3 and the denominator to be 1, and it's got to be positive. So I need y, so that'll be 60 degrees, root 3 over 1, and that's also going to happen at, I need the y value, so 240 degrees. So 60 degrees and 240 degrees. Okay, theta equals 60 degrees, 240 degrees. And that looks like it. So if I could find the done button, which there we go.